Welcome, everybody. So I hope you're in the right spot. We are in Deep Dive, Wildfire Links to Earthquakes, with Nicole Myers presenting today. It's great to see everybody's faces. My name is Carrie Winninger, and I am the outreach lead for the Center for Environmental Inquiry. And usually these events are at one of our preserves, either at the Osborne Preserve in Pengrove on Sonoma Mountain, or at our Galbraith Preserve, which is in Mendocino near Yorkville. But while we are all mostly at home, we're really happy to be able to reach out to you in these new ways and connect during these challenging times and learn a little bit about what we're all going through. So the first thing I'd like to ask you all to do is to take a moment to go into the chat, type out your name the way you registered, like your first and last name, because usernames and real names don't always match up. We don't know who you are necessarily based on your username on Zoom. Kind of like our sign-in sheet for the day. Thank you. You guys are quick. Great. And that's also a good exercise so you know how to use the chat function. So that's the way that you can communicate with me today. Nicole is going to present, and I'll be the one that's looking out for technical things. So if you have any issues with sound or Zoom, or you have to take off, you have a comment or question for me, then go ahead and type it in that chat and I'll be monitoring it. So before I let Nicole take it away, I want to tell you a little bit about what the Center for Environmental Inquiry is and how we can be a service to you, no matter if you're affiliated with SSU or not. Whether you're a student, a parent, government employee, member of the public, or maybe you work with an organization that's in need of environmental solutions, which is what we help with. So the center envisions a North Bay working together to find environmental solutions. And we invite you to get environmentally ready with us. So how are we going to do that? We're building a community of learners and problem solvers across all sectors of society by providing two key things: firsthand understanding of our connection with the environment and skill building experiences that result in sustainable solutions. There's many different ways that we're trying to achieve this and have you get involved. And so just a few examples of those are, you can engage in research, and that doesn't necessarily have to be traditional research, scientific inquiry. It can be an art research, or it can be psychology. There's all sorts of different ways to do research with our data and our preserves. You can take one of our programs. We have a naturalist program, which I know a few of you actually on this meeting are in right now. It's a virtual program this fall. We have a land management training program. If you're a student with SSU, we have jobs and internships and volunteer opportunities. You can receive service learning credit for your classes by working with us. You can access data. You can lead events like this. If you have a particular expertise, let me know and we can have you present to people about how you can tackle environmental challenges. And there's lots of other things. Partner with us on projects. We work with community members, nonprofits, government agencies, and corporations. So the whole idea is that all of you, are truly important in addressing the greatest environmental challenges that history has ever seen, as recent wildfires have witnessed. So a diverse, engaged society is critical, and we want you all involved. Today, we're going to talk about the links between wildfire and earthquakes, the topography, climate trends, and fire weather. This is one of our deep dive events, and what that means is it's a pretty simple format. Nicole will present 40 to 45 minutes, then we'll have 5 to 10 minutes for questions, and I'll just do a little 2-minute wrap up, tell you what's coming up next. And then please do feel free and email me after the event for any questions. Since you registered, my email is the one that you got in your confirmation email, winingek@sonoma.edu. Let me just admit a few other people here. Alrighty. So Nicole would love to see your faces while you are listening, but we are going to make sure that all of your microphones are turned off because that can be distracting. So it looks like most of you have already done that, but if not, if you could please do so. Otherwise, I'll have to go through and manually do that. And then we can turn your microphones on if you could please do that yourself at the end when we have the question and answer session. Now, everything else is under Nicole's purview. So I would offer that she share her screen, take it away, and I hope you all have a really great time today. Let me know if you need anything in the chat.
Hello, everyone. I'm so excited to actually give this talk. For those of you who have like the Zoom camera windows that are kind of hovering over the screen, just know that you can click on the black bar kind of above the video and you can move it around. So if it's blocking your view of one of the really important maps, we know that there's multiple views of Zoom. So I just wanted to make sure you knew that. And today I am going to be focusing on some of the links between wildfires and earthquakes, especially some of the ones that people just don't think about because maybe they feel slightly obscure. And one of the first things we would really like to know from you is how you heard about today's presentation. So if you can add this information into the chat, and you can just put in the number 1 if you learned about it through the Center of Environmental Inquiry emails. You can put in the number 2 if you learned about it through social media. And if you'd be specific, like through Facebook or through Instagram, that's helpful. If you learned about it through my Appreciating Earth newsletter, type in number 3. And if it was somewhere else, type in number 4 and then let us know where that somewhere else is. It's very helpful for us to know how people hear about this, you know, trying to spread the word and understanding really how it is actually spreading. So that's 1 for Center for Environmental Inquiry email, 2 for social media, 3 for Nicole's newsletter, and 4 for anything else. You guys are fast, like the numbers are going into the chat so fast I can barely keep track of them. Nicely done. Don't worry, there's going to be another one of these chat exercises at the very end, just to keep you excited. But I want to get on to why you are here, which is looking at earthquakes and wildfires. And I have so many pretty maps and diagrams for you today. And in the upper right corner of your screen is a Sonoma County hazard mitigation plan for historic fires. I find it to be a really interesting map because it color codes it by decade. So you can see that in yellow, and I'll make sure that's clear, in yellow, that's covering the years 1939 to 1959, so 2 decades of fire that we see in yellow. From 1960 to 1979, we see in orange. You see there's a lot more surface area, so there was definitely some larger fires within that 2 decades. In red, we see 1980 to 1989. In purple, we see 1990 to 1999. In blue, 2000 to 2009. In the darkest blue, 2010 to 2014. And then the lightest blue, which is on top, and you can see there's not much of it, is 2014 to 2015. And when we consider these hazard maps, which again, previous to the year 2017, we're going, okay, so we expect some wildfires every decade. Some decades are worse than others. But then what we've seen in the last few years has been much more intense than we ever expected. So we want to understand the patterns of these wildfires and how the frequency has increased and maybe what we should expect for the future. And then when we go to the bottom left, we have another hazard mitigation map, but this one is earthquake shaking potential. And if you see purple colors, that's worse news, whereas the yellow colors are relatively good news. So you can see that Santa Rosa, which is right through here, I know you can't really see the red on top of all of the other reds, is in a zone of extreme shaking. So we want to start understanding what some of the links are between these 2 maps, one which is earthquake focused and the other which is wildfire focused. So let's start with the earthquakes. Topography is the best place to start in trying to understand really why earthquakes occur and how earthquakes have built the topography that we get to enjoy today. When we think of Sonoma County in terms of geology, what we have is a series of northwest, southeast trending mountains. So I'm going to draw a red line in the upper left map that is northwest, southeast. And all of these thinner red lines that are already part of the map, every one of those is a fault. So we tend to think, oh, there's a couple faults in Sonoma County. Really, there are hundreds, if not thousands of faults. And those faults are constantly in motion to some degree, just very, very slowly. And they are constantly causing the topography to change. And when we look at a cross section, which is what we're seeing here at the bottom, so we see west is on the left side of the cross section, and east is on the right side. And I put a little yellow star here on Sonoma Mountain to give us a sense of where we are. And you can see that all of our valleys and mountains are bound by faults, many, many faults. It shows on this cross section that they are mostly vertical faults. That is fudging the truth, we'll just say. It's probably a little oversimplified. But I think the merit of this cross section really is the number of faults that we're looking at, and that they do have a vertical motion component to them, as in some of these faults are going to cause one piece of land or a block of land to move up relative to an adjacent block of land that might move down. And it is through that adjacent moving of blocks of land that we end up with valleys lower in elevation than mountains. So when we think of what a mountain is versus a valley, you can't actually have a mountain without a valley, and you can't have a valley without a mountain. Because if you think of what a mountain is, it's higher in elevation than the adjacent valley. And when we look at the northwest, southeast trending mountains and valleys of Sonoma County, which are parallel to all of these fault lines, what the fault lines are doing is they're accommodating shear and compressional stresses, the deformation mechanisms within our crust as a result of plate tectonics, which I'm getting to here shortly. What I hope these maps really show you is that we do have a lot of fluctuations in our topography, and really the faulting is to blame for that. Another thing I just want to point out on this map before I move forward is this little label. The label says alluvium and alluvial fan deposits. And the word alluvium essentially says broken up sediments, as in chunks, little pieces of rock that have been broken off of the larger mass of rock and carried downhill via gravity and via water to settle in the lower elevations. So we see that our valleys have lots of alluvium within them. And that's going to become a really important part of the story as we look at the hazards associated with earthquakes. Okay, so let's look at where those earthquakes are actually starting from. So we have the same map. I just wanted to have you have something that allows you to segue from the previous map. And we see right through here, I'm going to trace over the main splay of the Rogers Creek Fault. The Rogers Creek Fault runs through Sonoma Mountain, and we can see it's one of many, many faults. And what all of these faults in Sonoma County are doing is they're accommodating the fact that we have the Pacific Plate, that's a tectonic plate, a piece of the Earth's crust that is moving essentially northwestward, adjacent to the North American Plate. So the North American Plate is the plate you and I technically live upon. And we can see the western edge of this plate is also moving northwest. So we have these two plates. Here's the way I think of plates on Earth, because we need to remember that the Earth is in fact spherical. It's rounded. So if we tend to think of plates as flat, then we oversimplify the motion of them. But to oversimplify the motion of them, we have three different ways the plates can interact with each other. One of those ways is called divergence, when they pull apart from each other. Another way is convergence, when they come together or squeeze together, in which case one might subduct or go down. Or they translate relative to each other, what we call associated with shear stress, where one plate is sliding past the other. Now for that third one, transform tectonics, there's two ways that can take place, and this is specifically related to the San Andreas transform boundary. You can have two plates moving in opposite directions, or you can have two plates moving in the same direction, but one plate is moving faster. And that's exactly what's happening here in our neck of the woods. We have the Sierra Block, which is part of the North American Plate. It's moving northwestward, adjacent to the Pacific Plate, also moving northwestward, but the Pacific Plate is moving faster. So it's quite literally pulling ahead. So all of the faults that we have in our region are the result of these two plates squishing into each other and sliding past each other in the same direction at different speeds. This process has been going on for about 30 million years. And it was just after about 30 million years ago that we saw our Pacific plate and our North American plate meet for the first time. They came together, and because they were both moving in approximately the same direction, they ended up having this transform boundary. Essentially, the vast majority of the motion is horizontal, or essentially the shear motion that I was using with my hands. And I wanted to point all of this out because notice on all of these maps, it shows that the Pacific plate is moving northwest and the North American plate's moving southeast. Technically, that's not true. What they're showing is relative motion. For example, so my hands are on the camera now. We see that the Pacific plate has moved faster than the North American plate, so the offset makes it appear as if the North plate has moved in the opposite direction. But really, in fact, it just hasn't caught up. It's not moving as fast as the Pacific plate. And it's because of those differences in velocity, because those two plates are squeezing into each other, and I'm going to use my fingers to help with this one, as they squeeze into each other, the crust has to buckle. And some of the pieces are going to go up and create mountains, and some pieces are going to go down and create valleys. So all the mountains and the valleys of Sonoma County, as we see them today, are the result of those two tectonic plates squeezing past each other, moving in the same direction at different speeds for about 20 million years. That process has also lifted the entire land mass that we call Sonoma County up higher in elevation, so that it's been lifted out of the ocean. That's going to come into play a little bit later in the lecture as well. Just the fact that we're increasing in elevation, that's also going to play a part in essentially how much moisture is available underground. And now we get to how the weather is also going to play a part in how our county is going to be reshaped by natural processes. So topography that we just covered is a combination of that tectonic uplift, the result of the squeezing together. And then we need to go into erosion, because once you have the tectonic activity, the faults responsible for causing some blocks of land to move up and become mountains and some blocks of land to move down and become valleys. Now we have the topography that is going to be weathered. And the word weather or weathered in terms of geology means that when UV radiation and water and wind are pummeling the surface of the land day in and day out, changing the consistency of the rocks, causing the rocks to start to break up into pieces and become looser and weaker. That's what weathering is. And then erosion is the movement of those broken pieces downhill. That can happen via gravity, it can happen via water, could also happen via wind. But it's the weathering and erosion that tears down the mountains that have been built by the faulting, the tectonic uplift. So when we are looking at, I have to move something around so I can even put this here. When we're looking at our water flowing on the surface of Sonoma County, essentially what we're looking at is how water is behaving on the surface of the land as a result of the orientation of the mountains themselves, which we now know is the result of faulting. So in the upper right, we have a map that is showing our northwest, southeast trending mountains and valleys. And we can see those with the red lines there to give us a sense of that. So that's the trend of the mountains, the valleys, and the faults. They're all in sub-parallel to each other. But then our water flow in these regions is sub-perpendicular to those faults, valleys, and mountains, especially on the mountains themselves. We're going to find that the water moves from the top of those mountains and goes downhill in the easiest flow direction possible. And as a result, we end up with a lot of these rivers that have this orientation. And Sonoma Creek watershed is the best example of this. It's just very clear nature at its most organized. And we can see all of these rivers that are moving downhill perpendicular to the ridge lines, and then they congregate into a larger river that is now within the valley and moving parallel to the valley as a result of all of that water moving down the hill. And you're probably at this point going, why is she talking about this? Because when we consider how water flows down the surface of the land, we also need to know that air is a fluid. We tend to think of air as like all light and it's just going to rise up there and it's not going to have a direct connection to the surface, the solid surface of the land. But that's oversimplified, because if the weather is causing the air to be pushed down towards the surface, now that air, which is in fact a fluid, is going to start flowing along the surface of the land, and it's going to use these same water drainages to flow. And that's where we're going to come to fire weather in our future slides. But before I get there, we also need to consider what else the water is carrying with it. It's not just pure water. That water has pieces of rock, lots of sediment within it. And it's going to take all those sediments and it's going to bring them to the lower elevation valleys, and our valleys end up being filled up with alluvium. So the alluvium is the loose sediment, it's the remains of the mountains, the pieces of the mountains that have already been torn off and now have been carried down to an adjacent lower elevation. Now this is true outside of Sonoma County within California as well. We can see that our major rivers, as in the higher volume rivers, they run usually parallel within our valleys, parallel to our fault lines, and that many of our smaller rivers are running perpendicular to this. In terms of watershed, we call this a trellis pattern, where we have rivers kind of moving at two different angles. And that trellis pattern is oftentimes indicative of an active faulting region, which is of course true in this case. Now we finally get to our seismic hazards. So in this first map that's in the upper right corner, all of these dark brown reddish lines that you're seeing that are oriented northwest, southeast, parallel to my red line, those are all of our major faults within Sonoma County and Napa County. This is a map that's giving us a little bit of Napa County as well. And then what you're seeing as this dark brown color, like right here, those are areas that we are going to be associating with extreme shaking, as in when an earthquake occurs, we're going to see what we call violent shaking. For you and I, violent shaking, also on the Mercalli intensity scale, level 9, will be severe enough during an earthquake that you won't be able to stand and run. So obviously that's not good news. But it's also not too surprising to see that our most violent or highest shaking associated with earthquakes is going to be adjacent to and close to those fault lines. This next map, so halfway down our screen now, this is showing the same general concept, but we're now looking at the shaking that is going to be specifically associated with an earthquake on the San Andreas Fault. So we see that our San Andreas Fault actually runs right through here, right through Tamales Bay and through Bodega, right through there. So the worst of the shaking in the event of a San Andreas Fault earthquake is going to be adjacent to, close to the fault. So Santa Rosa will absolutely get strong shaking, but in comparison, I'm going to come back to this here in a moment. In comparison, if we have a Rogers Creek Fault earthquake, and remembering that our Rogers Creek Fault runs through Sonoma Mountain proper, now we can see the most extreme level of shaking is associated with that fault line, with Sonoma Mountain, and that fault line goes straight through Santa Rosa. So we compare these two maps. We have this map showing the San Andreas shaking hazards, and we have this map showing the Rogers Creek shaking hazards. It matters which fault has an earthquake. And then the shaking intensity, or how much shaking or earth movement is experienced, will be influenced by topography, as noted, the fault location, and then really important is the epicenter. Where is that fault going to initiate the motion? Is it going to be here north of Santa Rosa? Is it going to be closer to Petaluma? We don't know. We will never know until that actual earthquake occurs. But this shaking map is giving us a sense of what we should expect. And that is why the Sonoma County Hazard Mitigation Plan associated with earthquake vulnerability says that the Rogers Creek Fault and the San Andreas Fault are providing essentially equal shaking hazards in Sonoma County. But when it comes to an individual earthquake, where the shaking is experienced will be dependent on the epicenter of that earthquake. I also wanted to show you this map because, you know, just a little heads up about emergency resources after a future earthquake. All of the little H's you see are hospitals. All of the little P's you see, here's one right there, that's police stations. And then we have these kind of red black symbols, those are all our fire stations. Notice that the Rogers Creek Fault goes straight through the center of Santa Rosa and is adjacent to hospitals and police stations. The Santa Rosa Police Station and Memorial Hospital are practically right on top of the Rogers Creek Fault, and they're in a zone of very high shaking. That's not good. And it's good for those of us who are paying attention to say, after an earthquake, if I do need medical attention, don't go there, because those locations are likely to have been very impacted. So we need to be aware of where the emergency services are that are likely impacted and choose a different location to go to if possible. But we have another type of seismic hazard that we need to be aware of as well. So we talked about the shaking intensity. Now that shaking intensity is going to be experienced or transmitted through earth materials, through rocks, sediments, alluvium in different ways. As in, every material will behave differently depending on the type of shaking and essentially aspects of strength associated with that material. So in the mountains, where we see those mountains have been uplifted by faults, and many of our faults are on or adjacent to those mountains where we see extreme shaking, we're also going to be seeing landslides, and that's what this upper right map is. This is a map, the series of maps is coming from the Association of Bay Area Governments, and I'll give you the link of the interactive map, the GIS map source for this, so you can play with it yourself. I also have on this map the fault line, so this is the Rogers Creek Fault. And all of these regions that you see having essentially the darker colored teal, the darker colored teal, that's going to be zones that have more landslide activity with or without earthquakes, just in general landslide activity. But one of the things that we need to be aware of is during an earthquake, the mountains and the rocks that are make up the mountains, they're more likely to experience secondary hazards associated with landslides, as in, if the rock is relatively weak and already loose and then it experiences the extreme shaking, landslides are quite possible. So if you're in a mountainous area during an earthquake, be aware that landslides could be happening in the moment and immediately after earthquakes. So it's something to be aware of in the environment. But if you're in the valleys, you have a completely different kind of seismic hazard to be aware of, which is liquefaction. And that's what this bottom map is showing us. Again, we have those dark red lines through here showing us the locations of those fault lines. But now we see that our darker colors associated with higher hazard levels are now in the valleys. What happens in the case of liquefaction is essentially those loose sediments. And remember, they got into the valleys because rivers carried those broken, eroded pieces down into the valleys, and they've been accumulating and filling up the valleys for really millions of years. But those pieces of sediment are loose. They're not glued to each other. Here's what I think of when I think of valleys. I think of a bowl full of grape nuts. No, I don't technically eat grape nuts, but grape nuts look a lot like rocks. And if you have a bowl full of grape nuts and you start shaking that bowl, then the grape nuts are going to shake. But then what happens when you have some liquid in your bowl as well, like milk, or in the case of valleys, water? Now the way that those grape nuts shake with the water around them will be slightly different. And we can see that here in this short video, which is an experiment that was done in a lab, showing what happens to buildings that are sitting on ground that goes through the process of liquefaction during an earthquake. Now, they used essentially little pieces of glass as the pieces of sediment, but we can see that during an earthquake, these sediments are vibrating in such a way that they start to act like a liquid, and therefore any kind of building, structures, even trees that are sitting upon that material are going to sink into it because the ground is behaving like a liquid, and therefore anything atop it will sink into it as if it were a liquid. That means that if you're in the valleys, you have to be aware of liquefaction as a hazard, versus if you're in the mountains, then you're going to have to be aware of our landslides. Yikes. Okay, sorry, lost control. There we go, which is why you need to pack a go bag. Everyone, technically everyone in the world, but especially here in Sonoma County, where we've experienced a few natural disasters of recent years, knows that we need to be ready to leave our homes in the case that they are no longer the safest place to be. And one of the things that I'll be giving you towards the end of this lecture, this presentation, is a list of what you need to put into your go bag. Because your go bag is essentially saying the environment at home right now is not conducive to safety. I need to go. How can I have my most important things ready to go so that I can leave very quickly? I also wanted to take a moment to go over how humans influence seismicity, because we do have an influence in the number of earthquakes that can occur in a region based on how we're interacting with the ground below. When we think of these faults that cut through the crust, they're cutting through rock, the solid rock that we expect of the mountains, but also through that loose alluvium, that sediment material of the valleys. And that sediment material oftentimes has a lot of water in it, and we pump water out of the ground, and we make use of that for everyday use of water. A lot of the water we use is actually withdrawn from the ground. And that's going to play a part in how the surface of the earth is going to evolve in time. Because if we're taking water out of the ground, we're quite literally changing groundwater pressure. And that groundwater pressure is going to affect everything above it as well. So this is showing in the bottom left a kind of cartoon picture of a landscape where we have this solid rock, and we have all those wavy lines to say that's solid rock. And then we have these layers of the loose sediment. So we know that I'm going to put an X where we expect landslides during and after an earthquake. And I'm going to put a check mark where we expect liquefaction. If we take water out of these sediments, as we've done in this image, and we can see this below, then it changes the layering of those sediments at depth. It changes the water pressure. It even changes how those sediments are in contact with each other, because water pressure, if there's enough of it, will be able to push those sediments apart from each other a little bit and give them a little bit of space to move during liquefaction. Versus if they have settled down because there's less pore pressure underground, we've taken the water out, then all that material above it is going to have to settle down, and we'll end up with lots of cracks and ground fissures. And every time we see these cracks in the surface of the earth, they're not always indicative of a fault line, but often indicative of some kind of landsliding or subsidence of the surface of the land. And if we have an earthquake where this weakness already exists, we're going to have to expect quite a bit more motion here. So any cracks in the land are very likely to say, during and after an earthquake, this land has already been weakened by previous changes, and therefore might be a problem as we go forward. We also need to consider that when we withdraw groundwater, it also pulls the water down from the surface into that empty space. If we take the water out from depth, the surface water is going to sink. Just like if you have a glass with ice and beverage of your choice, and you put a straw in it and you're pulling the liquid out from the bottom of the glass, the surface liquid is going to sink down and fill that space. And therefore, we're going to end up with more droughty conditions on the surface. The last thing on this slide I want to focus on is fracking. When it comes to geology, there's really no question that fracking does in fact lead to a higher incidence or higher frequency of seismicity. Because what we do during fracking is we inject water down into the ground at very, very high pressures. Pressures high enough that it's going to force fissuring or cracking of the ground around that. By cracking the ground or by breaking up the rock at depth, it's going to free up the oil that was trapped within that rock. That oil is then going to mix with that water, and then they're going to pull it back out. That's essentially what fracking is. It's literally breaking up the rock at depth to get the stuff inside of it, the oil we want, the natural gas we want, and then pulling it back up to the surface to make use of it. And we can see here in Oklahoma that between the years 1980 and 2009, there was not a lot of seismicity. Each one of these dots is the epicenter of an earthquake. Bigger dot, bigger earthquake. All of them very small compared to California standards. But then they started fracking in this region, and look at how many earthquakes occurred between 2014 and 2015. 2 years, many, many times the number of earthquakes that had occurred in the 30 years previous. But that makes sense. We're quite literally breaking up the ground at depth, thereby causing fractures that are going to move, and that movement is what we call an earthquake. Another aspect of the evolution of Sonoma County is really looking at the climatic aspect of it. So we're kind of transitioning now from earthquakes into climate, but we're coming back to earthquakes, I promise. And we need to understand that for the last approximately 20,000 years, so about 25,000 years or so, is more or less the peak of the last glaciation. Now, in our last glaciation on planet Earth, where huge amounts of the water that are currently in the ocean had been locked up in solid ice in the polar regions, that meant that our sea levels were lower, and therefore our coastlines were much further away, further out to sea than they are today. For example, in parts of like Sonoma County, San Francisco regions, the coastline would have been 30 miles further west than it currently is. So dramatic change in sea level. And in the last 20,000 years, as a result of our interglacial climate change, which is just a word to say leaving the glacial stage and moving into a warmer stage. We've gone from a climate that was wet and lush to a climate that's increasingly dry and hot. So this is the natural climate change that's already happening. If humans were not here, this would be happening regardless. This overall shift, this interglacial climate change, is associated with decreasing precipitation. And we already see that here in Sonoma County in this bottom map here. This is showing our climate water deficiency that we expect in the years 2070 to 2099. So whenever we see these red colors, those are areas of the county that we expect to have that much more droughty conditions as a result of decreasing precipitation. But we also expect higher temperatures. And we can see this is the summer high temperature, bottom right, summer high temperature projections for that same future decades, where all these areas that are in red are expected to see extreme increases. We're talking an additional 10 degrees hotter on summer days, 10 to 12 degrees hotter. That increasing temperature and decreasing precipitation is going to be associated with regional droughts, therefore more wildfires, and of course, an increase in the evaporation rate. So any surface waters are going to evaporate away quite a bit faster. That evaporation, in addition to humans pumping water out of the ground, is going to cause our water tables to decrease. Now we have that water table decreasing situation, plus we have the uplifting of land associated with our tectonics, the fault lines, and that combination is going to lead to less surface moisture. And that's not even taking into account the decrease in the amount of snow we expect in the Sierras and how that will affect our water situation going forward. Really what this is telling us is we're moving into a much more droughty climate. And that's the natural part of climate change in the first place. We're just kind of speeding up that trend by increasing the atmospheric temperatures through human interactions. So when we start to look at our more recent wildfire patterns, we need to take some of that geologic information as well as this interglacial drying information. And when we look at these smoke plumes from fires in 2017, in 2018, in 2019, and I'm leaving 2020 out of this for a very good reason that I'll get to, and we come back to our hazard mitigation map, and we start to realize that there is a pattern. And that pattern for these very, very big fires that spread very quickly within a couple days tend to have this northeast to southwest trend, as in the fires spread in that direction because the wind is moving in that direction. But it's not just the wind, it's also the topography. So we need to understand how topography plus wind are interacting with each other to create these disasters. So what is fire weather then? Fire weather on a meteorological level, I would need like days and days to really talk about high pressures versus low pressures, but I'm going to simplify it to the best of my ability, given the time that I have. And in this upper right image, it's a GIF, so it's actually showing you a little bit of motion to it. It's showing you what happens to air when there's a high pressure. So essentially, the air moves in a clockwise direction for high pressure. What high pressure means is that in this region of the atmosphere, the air is being pushed down. And as the air gets pushed down towards the surface of the earth, so my lower hand is going to be like the mountains towards the surface of the earth, that increase in pressure is going to pressurize the air at the surface. That increase in pressure will therefore lead to an increase in temperature. And now that air has to go somewhere, and since it can't go down into the ground because the ground is solid, it's going to have to flow along the surface of the land. And we can see within this GIF image in the top right that it also is going to have to flow around the topography that's present. Notice here where we see it take this turn, that's it, the air flowing around the north part of the Sierras and then making its way through the valleys and then coming out through the San Francisco Bay. So we understand that as the air gets pushed down, it's going to have to essentially flow around the topography. And that's essentially what Diablo winds are, and Santa Ana winds. These, what we call wind events, occur when there's a high pressure just to the north and the east of us, and the air has this clockwise rotation associated with high pressures in the northern hemisphere. And now we have this air that is blowing from the northeast. That northeast, that wind from the northeast is coming from the continent, so not from the ocean. Because it's not from the ocean, it's going to be drier. And because it's coming from the continent, the interior of the continent, it's also going to be hotter. So think of continental air as relatively hot and dry versus marine air is relatively cool and moist. So now we have air that is hot and dry, and now it's going to be moving from northeast to southwest, perpendicular to the orientation of the mountains in the valleys. And we can see here in this image that that warm drying air gets pushed down onto the surface and it creates what we call a mountain wave event. Essentially, the air moves in a wave up and over the mountains as it makes its way out to the ocean. But any place where that air can essentially move around the mountains or find a low place in the mountains, it's going to flow with greater ease. So the important part of this is the high pressure determines the wind direction, as in the wind is coming from the northeast. The high pressure also is associated with a higher velocity of air because now you have this huge mass of air that has to go somewhere. Think of like when you have a hose and the hose is on and you have this volume of water coming out of the hose. But if you put your thumb over the hose, the same volume of water is coming out of now a smaller region. And so now the velocity of the water increases. That's not that much different than what's happening in a high pressure situation. the air has to move faster because it doesn't have anywhere else to go. So same volume of air being forced to move very quickly in order to get out of the way of incoming air. And when we look at what happened in 2017, this is, these are wind, essentially what we call wind roses associated with the 2017 event. We have two, one from Geyser Peak and one from Sonoma Mountain. You can see these are from the night of October 8th and October 9th. This is showing the wind direction from which it originated. Winds are always named by the origin. So these winds are northeasterly winds and northern winds. And we can see that for both Geyser Peak and Sonoma Mountain, the winds were very strong. The darker colors mean higher strength or higher velocity of winds. The winds were very strong from the north and northeast, which means we have dry, warm winds coming in. As a result, it pushed the fires that had ignited for a number of reasons, some of them human, most all of them human caused to some degree. And it pushed them in the direction the wind was blowing. So we consider these wind-driven fire behavior events. So think of fire having two different kinds of behavior, wind-driven versus terrain-driven. And we can see all the red dots. The red dots are showing how the fire spread on the 8th and the 9th. And then look at how the wind patterns changed as we go into the subsequent days. This is showing for the 10th through the 17th of October after the major wind event. The winds calm down. They're no longer coming from the northeast, north. They're mostly coming from the west and east, kind of oscillating back and forth. And all of our yellow dots here are showing how those fires, which had already begun, start to spread out in those directions. But those initial fire spreading from the northeast was driven by those northeasterly winds that we call the Mount Diablo or the Diablo winds. And when we look at wildfire history within Sonoma County, we know that there were major fires, all of which are associated with these northeast Mount Diablo wind events in the years 1870, which they call the Great Fire. It's quite literally just the Great Fire. 1923, 1964, the Hanley Fire, 2017, and 2019. So we'd have this closer to 50-year frequency or interval between these fire events in the past. And then recently, we're seeing them a little more frequently. We also need to know that there are 4 major wind corridors within Sonoma County. And here in the bottom right, where we have this map, this is showing by year. So the lighter colors are showing, like here, are showing fires that were before the year 1965. And then as we go darker in colors and these kind of mauve colors, we're seeing more recent fires. But notice we have these trends from the northeast. That's what fire weather is. Fire weather is when the atmosphere is conducive to bringing warm, dry air that moves very fast. Now, one of the things we also need to consider is what all these corridors are topographic canyons. When we look at that northwest, southeast trending mountains, we see these gaps between the mountains. And those gaps are the canyons that the water has eroded over the course of time, creating those deeper topographic lines that are perpendicular to the faults and oriented northeast, southwest. So when the winds now align with those deeper canyons and the wind is being pushed down, the wind is being forced through those canyons at much higher velocities. In the same way that when you put your thumb over a hose, you're forcing that volume of water through the hose very, very quickly because it's still the same amount of air water still has to come out. When we consider natural fire return intervals for this region, which is based on frequency of lightning events in Sonoma and Napa counties, every 50 to 100 years, we expect a natural wildfire event, oftentimes made worse by one of these Diablo wind events. But then when we consider how often fires occur more recently, we have to bring in that 85% of wildfires that occur around the world are started by humans. 85% of them. So we already have a massive increase in the amount of wildfires that are occurring. Then we have the consideration of fire suppression. Now for this region, there's some argument as to whether or not suppressing wildfires for the last number of decades has actually caused the problem to be any worse. If we look at how Native Americans used intentional burning to change the landscape for any number of reasons, it's very likely that pre-Americans, as in the Native Americans, actually increased the rate of fires that were relatively controllable. And since then, we have had fewer fires because we have tried to suppress the fires. There are some scientists who are actually trying to argue that we need to look at historic fire rates in terms of human caused versus lightning caused, and it's really difficult to do so. And there's more changes that have been wrought that we need to consider in terms of fire frequency as well. How the ecosystems have changed. We as humans have brought in so many non-native plants that have changed the way that fires burn. We've also changed land use so that we've built buildings where there never were before, and every single material burns at a different temperature. So by having homes in areas that are fire prone, if those homes burn, they might actually increase the temperature of the fire and therefore change the way the fire spreads. Really, the only things that haven't changed in our landscape recently are going to be the geology and interglacial climate change. Everything else about our climate has changed. And one of the things I really recommend doing, and I'm going to put this on my website so you can explore this yourself. This is probably one of the most interesting websites to look at in terms of fire history, where you can actually look at the rate of different wildfires over the course of time. And I just am going to go through this quickly because I know I'm running out of time. So we're now at 2015, 17, 18, and we see that the fires are getting bigger. And one of the things we need to understand is that we have our fire hazard regions, but then we also have an increase in the number of these very large fires. And there are a lot of factors that go into determining this. But for this talk, really what we're looking at is how the topography and the winds, when they come together, create the big natural disaster, as in these large fires that we've been experiencing. Okay. And as we look at, I lost control out of my cursor. That's an interesting one. There we go. And as we look at some of these maps from 2017 and 1964, we can see that these fires have taken the same route each time, and that the fires the winds originated from the northeast. That means next time we have a wind event that we call a Diablo event, we need to be really aware of our environment and know that those winds are conducive to very fast spreading of fire. So if we know northeast winds are coming at high speeds and you know there's already a fire that exists to your northeast, that's when you are more aware of your surroundings. Because when the Tubbs fire occurred in 2017, this is how it spread. Very, very quickly from the northeast to the southwest, essentially all in one night. And if we had been more aware of how we needed to prepare for this, then we would have told everyone to the southwest of that initial fire to evacuate that night because of the possibility of this fire spreading. Okay, as usual, I had like 1,000 more things I wanted to say. But I hope that what you got out of this is that Sonoma County natural hazards are a result of ongoing geologic and climate trends, in addition to how humans have affected the surface of the planet. What we would really like to know from you today, if you would add this to the chat box, is what related topics are you most interested in learning about? You can use the number system. Again, you can just type in 1, 2, 3, 4, 5 for each of the possibilities I have listed here. But I've also posted on my personal website, which is appreciatingearth.com. I have a web page called Emergency Preparedness Tracking, where I have given you a link to a go bag packing list and a link to a whole series of websites that are associated with fire weather watching, earthquake hazard mitigation, and earthquake hazard interaction maps. You can see if your home is more subject to landslide or liquefaction hazards. There's also a ton of websites there that are helpful for any other kind of natural disasters, because that's what I do. I really am always highly aware of what disasters are available or hazards are possible in any one area and what we should be doing to prepare. And on an individual level, prepare your property for fire by landscaping. Consider that we don't want any very high bushes or trees nearby the house. We want to have as much fire break around the buildings as possible. Educating yourself on like day-to-day weather events, as well as what hazards are present for your specific neighborhood. Being aware of the land use in your area and how you can maybe change that through voting. And generally, when we have the opportunity to vote, maybe vote for people who are there to help us make our environment a little more safe as we go forward. Okay, Carrie, I totally went over as usual. We're not surprised by this, but if we have questions, I can stay for a few questions.
So what I'm actually going to do is just jump straight into my kind of outro talk, and then we can stay afterwards for questions, because we did have some good ones, but some people might need to leave right away and I want to get them some information.
Thank you guys so much for joining me. I hope you enjoyed it. Visit my website, send questions if you have them.
Truly, I mean, this was so interesting, Nicole. We had multiple people asking about if it's recorded, if we can have your slides, and yes, it will be recorded. It will be posted online at the same place where you registered. So that same event page, you can go back. It'll be up in a few days here, and you can share it with your friends. So some couple housekeeping things. Please make sure you've entered your full name in the chat. We really want to make sure we can record who attended. And I'm going to send out some follow-up materials afterwards. So I need to make sure that I know who you are based on your username so I can send you that email. Feel free and email me if you have any other questions or comments or ideas for events. And I also want to tell you about a few events that are upcoming, as this is just the second in a series of almost a dozen events coming up this fall. And you can find that whole list at cei.sonoma.edu/calendar. And maybe I could even ask Julie to type that in the chat right now for everybody. Julie is our naturalist program coordinator, and she's on the meeting today. So first up, tomorrow is a really special event. So it's called Inmersión Profunda, Tortugas Marinas y COVID-19. It's in Spanish, held by an SSU MS graduate, now working toward her PhD in biology at UC Berkeley, Gabby Arango. And she's also the co-founder of a nonprofit called Crecer Conciencia. So she's really passionate about sharing her love of science with the Spanish-speaking community. And in this case, she's going to talk about how COVID-19 and the pandemic is actually contributing to ocean pollution and making it more challenging for scientists who are doing sea turtle conservation. Really interesting topic. I'll be there for tech support, but it is fully in Spanish. So please, we'd be appreciative if you would share this information with anyone you know who speaks Spanish, would like to practice Spanish, and would be interested in this topic, because we still have quite a few spots available. And I have actually put the link in the chat for that event if anybody wants to share it with anyone they know. And then 3 days from now, on Saturday, is an event called Deep Dive Shifts in Land Management. And this is by a cultural resources grad student at SSU who also trains our naturalists, James Peterson. And he had an event last spring that was very successful. And this is actually the first and a part of two. The next event will be in spring. Not just this first event will talk about the historical pieces, and next spring we'll talk about some recommendations for future. Then next Monday, on September 21st, is a really different kind of event. So it's really casual, really informal and interactive. It's a learn with a naturalist event called Get Curious in the Outdoors, which we all want to do, I'm sure. This is held by a naturalist from our program, Sabrina Hurst. Should be really fun. And so we invite anyone who, it is for adults, but you know, younger folks can attend too. And we're going to look at feathers and acorns and how we can just see something and then actually teach ourselves how to learn, giving you resources and ideas for how to investigate these things. And then next Wednesday is another really special event that's a part of a different series. So this one is part of the Virtual Field, which is a project put together with an NSF grant with an international collaboration of field sites. And it's really helping to get students, mostly university students, but anyone's welcome, to have an idea what it's like to get in touch with a researcher, and 3 different sites around the world will be joining. So we'll be getting to speak to people all across the world. This time we'll be talking about harmful algal blooms in freshwater, which is really a threat to economy, recreation, and health, both for humans and for the environment. And so students will have then a chance to watch videos filmed in the field and then ask researchers questions about their background, how they got involved, and anything about the topic. So that's another thing that I would encourage you all to spread the word to faculty and to students. We're hoping faculty can even bring their classes to these events in lieu of field trips. And then lastly, I just wanted to mention, because Nicole mentioned invasive plants and fire, that Problem Plants is another event we have coming up in November. And the science director at Cal IPSI, which is the Invasive Plant Council for California, is actually going to be talking. And in her description, she talks about how wildfire are connected. So those are all things to look for.
What about Dave?
Sorry? I think
Really?
somebody unmuted, if you can mute yourself still. And then lastly, I just wanted you to say that virtual events, they can be attended from anywhere. So we're not limited to people that are nearby. So spread the word far and wide. And we'd love to see you all again at one of our events. So thank you so much for attending. Stay safe. We hope to see you again. And we'll stick around for some more questions with Nicole. And now at this point, if everyone wants to ask a question, they can unmute themselves or you can type in the chat. We did have one question come up, Nicole, that I could ask you now.
Go for it.
So Henry was asking, he says he lives in Lake County and he's interested in the effects of volcanic activity and pumping of water into the ground to change geothermal power plants.
Ooh, that's a really good subject. That's actually one of the very first scientific papers I did in high school.
Oh,
so
good.
Essentially, exactly. I'm like, back in the day when we were first putting those pipelines up to the geysers to take our wastewater, which was, you know, partially treated, by the way, so it's not as bad as it sounds. And we take our wastewater and we bring it up there. And what we're doing is we're injecting the wastewater down into the ground in the Clear Lake area where there is active volcanism. So the rock at depth is warm. It's anywhere from warm to hot, depending on proximity to active magma chambers. And what the goal is by taking that relatively cooled water and putting it underground, it gets warmed up, and then it will naturally turn into steam, and that steam will rise through a different tunnel, different vent, and it will turn a turbine, and we'll be able to get relatively clean energy from that. But just like as we looked at through fracking, if we're injecting water, pressurized especially underground, that water has to go somewhere. And there are natural cracks in the ground through where a lot of that pressurized water is going. But if you take pressurized water and you push it underground, it's going to expand those cracks, and that's going to lead to small scale earthquakes. So we know that there's an increase in seismicity associated with that form of geothermal energy in a region that already has a lot of seismicity. As far as studies saying whether or not it's a profound change in seismicity, I have seen a lot of papers that completely disagree with each other. But I think it's very clear that there has to be an increase in seismicity because we're increasing the pore pressure underground. Whether or not that's causing bigger earthquakes, I don't think there's enough data, but I don't think we have any real evidence to say that geothermal injection of water is increasing the severity of earthquakes. Does that answer your question, Henry?
It does, and I just like to say I'm totally jealous. I would love to see this similar presentation about Lake County because it's totally different topology and the different things are happening, but equally, of course, hazardous in the fire situation. And you have presented
Absolutely.
this much better than I've ever seen it done before. So
Well, thank
I like to
you.
say it really was very useful, even though now I have to make up all these facts about Lake County in my head through my complete ignorance and try to figure out how it applies.
Well, many of the maps that I provided, the websites that I'm also putting on my personal website, kind of a source list, some of them actually go into the Lake County region. So you can investigate maps that I put in this presentation for that specific region.
And what is your website?
It's appreciatingearth.com.
Great, thank you.
Absolutely.
Nicole, there are so many comments of people that just had a really great time and love your presenting style and are so happy they came. So there's lots of positive feedback. Let me get to another question. So Pam asks, how was the Walbridge fire different from 2017 and 2019 fires?
And I purposely chose not to go into that today because the fires that we've experienced thus far in 2020 are not fire weather events. So hopefully what was clear in today's presentation is that a fire weather event is associated with that high pressure region causing warm, dry continental winds to flow from the continental interior. And because of the way that air is forced down onto the land and therefore through the gaps in the topography, it gets funneled through and causes the wind velocity to increase. And that's when we get those horrific events. But 2020 was different, because in that case, the wind was coming from the west. And the reason we considered it unprecedented in terms of the data that we have meteorologically, weather data from the past, is that we had these large thunderstorms rolling through. So a lot of the studies of Northern California that look at the lightning incidents, like how often does lightning strike within this county, Sonoma County and Napa County have the lowest lightning incidence of the entire state. We just don't get a lot of lightning based on our weather. Therefore, the number of lightning-caused fires are lower in these two counties than anywhere else. And a lot of that has to do with just the way the weather moves through the North Bay region. But the Walbridge fire was caused by lightning. And this is the weirdest part. There was a hurricane at that point, and I can no longer remember the name of it because we've had so many freaking hurricanes this year already. And this hurricane was off the west coast of Mexico, and it headed northward, and it stayed relatively close to the coastline, more so than usual. Most of our hurricanes tend to go westward. And this one, it stayed hugging the coastline, and it brought a huge amount of moisture up towards Northern California. And then a low pressure essentially pushed those thunderstorm clouds to the east and over us. So we had this very wet west to east storm that brought lightning. And that lightning is what caused the fires. And that's also why when we look at the Walbridge fire, it was forced eastward, not like these other fires we look like that were forced westward, because it was wind driven by those thunderstorms. And then once the thunderstorms were done and the wind calmed down, then it spread out and became a terrain-driven fire. And what a terrain-driven fire is when the wind is not doing most of the job of spreading the fire, but now topography is causing the fire to move uphill, what we call a fire ladder. So what a fire ladder is if we think of a tree, and there's a fire underneath the tree, my thumb's supposed to be a fire, by the way, then that fire can catch the bottom limbs of a tree on fire. And that's going to cause the fire to move up that tree. But now there's an adjacent tree and it's going to catch fire. So essentially an uphill trend. The fire spreads uphill because the plants and the shapes of the plants can allow that fire to move in the uphill direction. Again, that's called a fire ladder. So when it's a terrain-driven fire, it's going to move uphill. When it's wind-driven, it's whatever the wind is doing, that's what is where the fire is going to go. For Walbridge, it was actually west to east because of thunderstorms.
Wow. I just want to say a few of these positive comments because people are being so descriptive. They're saying, you're a wonderful speaker, making a complex subject understandable, easy to follow, great use of graphics, learned a lot. Ever the amazing educator you are, Nicole. So people are really happy. One more question that was typed in. Well, actually a comment first. Julie said that she was always wondering if purchasing earthquake insurance was worth it. So this was really helpful.
Well, you know, I'm going to do the earthquake insurance thing for just a moment. I'm not an insurance broker, and technically insurance actually makes my brain melt out of my ears and I don't comprehend it. But I've talked to multiple insurance brokers, and the number of them are like, earthquake insurance is very expensive. And if there's a very large earthquake, everyone's going to be drawing from the same earthquake insurance at the same time. Will that earthquake insurance company have enough money to pay out to everyone at the same time? Is a serious question when it comes to earthquake insurance. I'm not saying don't do it or do it, but I think it's worth talking to insurance brokers to find out whether or not it is financially worth it.
Always good to look into things more.
Mm-hmm.
So then the last question that was typed in, unless someone has more to say, and feel free and say these out loud too, everybody. David asks, is there any correlation between organic material and water in topsoil and natural hazards?
Yes. Well, when the soil is moister, as in essentially there's a higher pore pressure towards the surface because we've had more recent rain or artificially we've been watering, that's going to have a direct surface moisture translation into the atmosphere. Think about it like, for example, if you know someone who has a lush garden because they water it all the time, and then you go to their house on a dry day and you're like, oh my gosh, it feels so much better here in your garden. It's like the humidity is higher. It literally is, because those moist plants and the moist ground are going to translate some of that moisture into the atmosphere. So when we look at the humidity of the air, it is going to have direct linkages to whether or not the groundwater table is relatively low, therefore droughty, or relatively high during wet season. And then that ground level water is going to also affect how much water can be uptaken by the plants, and therefore how much transpiration or outward breathing of water into the air through the plants can take place, which will also impart more moisture or less in the atmosphere. So absolutely, when it comes to organic material and the water translation between soil and atmosphere, it will have a huge effect on local humidity. Does that answer that question? Maybe.
Not even sure if David is, I think you're still here, David.
Mm-hmm.
That's it for the questions in the chat. So, oh wait, someone else might be. Could we change the micro?
Could I offer a question?
Sure,
Yes.
go for
Can
it.
you hear me?
Yes.
I was wondering if the ice melting in the North Pole and all the glacial melt could increase our plate movement here.
We have no reason geologically to think that changing sea levels are going to have a direct impact on tectonic motion. In other words, if we look back in history and we can look at the fluctuations in sea level, which is also going to, in many cases, but not all, match the fluctuations in the amount of ice in the polar regions, we don't see any change in the velocity of plate motions and therefore the number of earthquakes to coincide with that. So the short answer is, when we consider increasing sea level, we do not expect there to be an increase in number of earthquakes. We don't expect any change in tectonics, because the energy that causes earthquakes and tectonic motions is sourced from deep inside the earth, the heat of the core. And the source of the energy that is driving weather in the melting of the ice caps, that energy is sourcing from the sun. It's the solar energy. So two different energy sources that aren't going to affect each other very much, which is good.
At least
I'm really glad to say, at least as far as climate goes, at least the climate change is not going to, as our current data shows, technically change the number of earthquakes. One good piece of good news.
We do have another question.
Thank
Yuriko wrote, could we change the microclimate of a place by planting groves of redwood trees to calm the wind and also catch the moisture in the air?
Oh, that's a good one. We can absolutely change a microclimate by changing an ecosystem. We know this because we've done it in reverse. And one of the things that I really wanted to get to, and then I looked at the time and I was like, skip over, move faster, is we need to consider that we have changed the ecosystem dramatically since the mid 1800s, bringing in cattle, cutting down forests, huge lumber industry early on in the American settler days, that profoundly changed the ecosystem. And if we change an ecosystem, it changes atmospheric moisture levels, it changes how wind is able to move through a landscape. It's also going to change, of course, which animals are present within that ecosystem. It's going to change how often fire goes through and how destructive that fire might go. So we've changed the ecosystem unconsciously and unintentionally in the past, and we're seeing some of the results of that. We can absolutely consciously and intentionally change the ecosystems going forward through better land, through more conscious land management, and have the effort towards making positive changes, which there's a lot of evidence that suggests that Native American tribes that lived here before the American and European settlers took over, that they did regular, intentional burning of certain landscapes for very specific purposes in order to, in many ways, change the ecosystem to get out of it that which they wished. And in some cases, it was simple as burning a riparian area to decrease the amount of overgrowth so that some of the areas that they relied upon to get the right grasses to make their famous baskets, post burning, those grasses came back and they had more of that material available to them. I think that's amazing. So we have a history in this region of intentional ecosystem changing through intentional burning, being conscious of how that change will take place for positive impacts. The problem is if we've gone through over 100 years of unintentional ecosystem changing and not understanding what the results would be.
Well, that's all of the questions in the chat, but feel free and speak up. I think Nicole has, I mean, we've already stayed another 20 minutes, so we can't stay too much longer, but we can squeeze another one in. Oh, we just have another positive comment. With the current pandemic keeping me inside, I've been seeing a lot of lectures on Zoom. Without a doubt, this is the most interesting and well done I've seen. Wow, thank you. You're a very talented teacher, and I'll be taking a look at your website. Thank you.
Oh, wonderful. And for those who are still here, I have expanded my website, and I'm going to start offering essentially socially distanced geo field trips so that I can teach in the wilderness in a safe place. And I'm also offering like tutoring for school kids who need a little bit of science. I've been doing that for one family. It's been so much fun. I'm also offering like natural disaster preparedness, like half-hour sessions of like, for those of you who are just like, I need to pack a go bag and it's been 4 years and I still haven't packed a go bag. What is my problem? This would be me being like, you need to do these 3 things like now. We're going to start with these 3 things and we're going to move you towards a feeling of being prepared so that in many ways we can get our anxiety down. So much of the anxiety around these natural disasters is, what do I do? And if you have some of that information and you know what to do, maybe your reaction can be a little less sporadically random next time things happen. Especially if you're one of those people who goes, what do I do? As soon as something starts going wrong, then I'm basically offering the ability to help you find a little more calm during those situations. Educated calm.
And I really do encourage you all to look at her website because though she is a professor here at Sonoma State on some specific topics, she has a wide breadth of expertise and offerings. So go take a look at that to see some things you might not expect Nicole to be helping everyone with too.
Well, thank you so much. This is so much fun. This is my favorite kind of thing to do. It makes me think about things in a whole different way every time I put one of these presentations together.
Well, we are so lucky to have people like you join us, Nicole. It's been such a pleasure. Thank you for being here again. We hope to see all of you at other events in the future. And please, once again, don't hesitate to reach out to me for anything at all, ideas, questions, comments. And I think I'm going to sign off.